S.D. Poisson was a French mathematician who was first to develop a variable queuing theory. He created a distribution function to describe the probability of a particular outcome after repeated trials. Using a statistical approach, his distribution could be used in any situation where excessive demands are made on limited resources. An example of this was in the 1800s, when telephone companies sought out a solution for placing a certain amount of operators to handle phone calls coming in. At this time, operators still had to connect each caller manually. Poisson's version of queuing theory was only meant to handle callers who called repeatedly until an operator finally answered. He failed to address the callers who would stay on the line and wait. A.K. Erlang, a Danish mathematician, developed a different approach to traffic engineering. He based his approach on Poisson's work and developed formulas for calls abandoned, which he called Erlang B, and those which held until they received service called Erlang C. With Poisson's formula, along with Erlang's, they were finally able to address the unpredictable behavior of callers. Through normal distribution, they were able to determine that unusual calling characteristics in one moment would be normalized over time to yield a more normal distribution. The simplest way to explain it is a mathematical method of analyzing the congestion and delays of waiting in line, not just people standing in line. It also applies to industrial bottlenecks, warehouse distribution, and the dreaded call center. When you call for any type of service, this is the last thing you want to hear. Queuing theory can help bring 97 minutes down to a more acceptable number. A few ways queuing theory can improve our day-to-day lives is by lowering customer service wait times, reducing traffic congestion, helping you get products delivered more efficiently, and developing more user-friendly telecommunication systems. Queuing systems can solve many commercial problems, such as system manufacturing, deciding the layout of a parking lot, and how to set up a retail store's checkout design. Here are some examples of queuing theory. A defense industry contractor had to create a timetable for delivery in order to gain another customer. The queuing theory helped predict where bottlenecks were happening, which then allowed for more resources to be brought in and delivery deadlines to be met. When designing a parking lot layout, many factors were considered, such as entrance and emergency exits. Each store is taken into consideration because the access points are different at all malls. Lastly, a high street retailer is told that they needed new cash tills because the manufacturer did not support them anymore. They took into account many tills that were needed for each department and how it would affect their customer experience. They used queuing strategies to decide if a single queuing multiple till bank would be the best or if multiple till banks of their own queue would be better. By using this, they were able to figure out that a single queue with multiple till banks was more efficient for customer satisfaction. The queuing theory can be very beneficial when applied properly. Many of us don't even realize the cost until it is put into perspective.